So hello everyone, I'm Robert Pająk. I have a Pelared handle on GitHub, and I'm also a maintainer of OpenTelemetry Go. And today I want to discuss a common topic among Go teams. Should we use testing libraries such as Testify? I've been passionate about testing and automation for over a decade. Through that time, I've explored a variety of testing approaches, techniques, frameworks, and here are some testing-related books that I've read along the way. When I transitioned from .NET to Go, I also had to adapt my mindset and learn how testing is approached in the Go ecosystem. So now, guys and girls, I need your help. Can I ask everyone who writes unit tests in Go to stand up, please? Everyone who writes tests. Yeah, cool. So now, can those of you who use Testify library sit down? Who use Testify, sit down. Yeah. And now, Ginkgo and Go Mega users. Are there any? Yeah, sit down. Okay. Next one. Go Convey. Is anyone using Go Convey? Sit down, please. And then lastly, we're just using the Go testing framework and nothing more than that. Cool. Okay. Probably a lot of you came across Testify, Ginkgo, and Go Mega FIC, and maybe even Go Convey at some point. Each of these testing frameworks has a bit of history and context behind it. Testify follows a design similar to XUnit style frameworks like JUnit, popular in Java, XUnit from .NET, or NUnit, Python, and PHP. All these languages usually use XUnit style frameworks. On the other hand, Ginkgo and Go Mega is an RSpec style framework that has gained strong traction, particularly in projects related to Kubernetes. Testify is by far the most popular assertion library in the Go ecosystem. And what is interesting, according to PKG Go Dev data, roughly 15% of open source Go packages uses Testify. And most of the others rely just on the testing package from the standard library. However, here are the results done by JetBrains that take also into account closed source code. We can see that sticking just to the standard library is still popular, but the difference is no longer significant. So for example, for you, as you see, most of you are using Testify. And this is in line with my personal experience, where most enterprise code bases use Testify. Notice that most professional developers are working on large, long-lived code bases, and even according to GitHub's State of October's annual reports, small number of large projects have the highest contributions and engagement. However, I often wondered why the official Go testing guidelines, so for instance, Go test commands, which is maintained by the Go team, advise against using assertion libraries such as Testify. It's especially intriguing if you consider even how much of you had basically sit down after I asked you the question, who uses Testify. I use it myself, and I know how much boilerplate it can remove from the test code. I still remember the first time I looked at the code of the Go standard library, and it felt for me very awkward and noisy. But over the time, I've come to understand the reasoning behind Go more minimalistic approach to testing. And today I want to challenge the common practice of using assertion libraries in Go and explore what we might gain by rating tests the way recommended by the Go team. Here's our roadmap for today. We'll talk through the 6 topics: line of sight in code, precise failure messages, assertion conditions, equality assertions, structuring tests, interaction testing. And there's also a bonus topic at the end. I've prepared some examples to highlight the implications of using and avoiding these testing libraries, and I will use Testify as the main reference since, as we have seen, is the most widely used assertion library in Go. Most of what is going to be presented, but also applies to other test frameworks such as Ginkgo or Go Convey and others. Let's start with the first topic, something which I call line of sight. Here's a typical and simple example of a test using testify as an assertion library. Testify encourages one-liners for doing assertions. In contrast, Go standard approach makes us write more upfront, but our brain can follow the flow more clearly. Writing tests using if conditions should not only feel natural, but even more readable for us, since who is not used to the not equal to nil return pattern, which you use in the production code? Who isn't like familiar with this convention? This pattern, like the familiarity is a key characteristic to make the code clear and readable. And in Go, the happy path is unindented, so it's on the left side, and error paths are indented on the right side. This pattern can be also handy during debugging, as we can set breakpoints at the lines with TRF or tfattlf, which can be very convenient when using table-driven tests. And here, a sentence from the Go code review comments. Try to keep the normal code path at a minimal indentation and indent the error handling, dealing with it first. This improves the readability of the code by permitting visually scanning the normal path quickly. Basically, in my opinion, test code is no different than production code, and we should follow most of the guidelines for test code in the same way as production code. Precise failure message matters. This is the second topic. We want our test failures to clearly communicate what exactly went wrong when the test failed. Usually when we use testify, you'll see just expected versus actual in the test failure output. However, such failure output lacks more detailed context. When using the standard library, we format failure messages ourselves. It's a bit more effort, but the test output is often much clearer and more informative. Yes, it means writing more code, but isn't Go in some ways about embracing writing boring Go code? Avoiding assertion libraries can actually encourage us to think more carefully about failure messages, and that can lead to better test output and better test overall. For instance, in this example, the failure output contains the test input, as we can see here. Tests should fail with helpful messages saying what was wrong, what input, what was actually got, and what was expected. And this is also from the Go code review comments. Assertion conditions is the topics where things are getting a little spicy, in my opinion. Okay, so let's talk about assert eventually with T. Most of you know testify, so probably you're aware that basically this function or assertion waits until the past assertions do not fail. However, this test fails when running Go test with raise flag, because there's a raise condition. Let's check the function documentation. So as you can see, what is interesting, this is a copy paste of this code, and it fails. So this assertion, which is in even their documentation, isn't concurrent safe in a ways you would expect it to be. Who knows what's going under the hood? Contrast it with the standard library approach, where we write our own virtual test loop. Let's look how the initial version of the test look like, and if we not use testify. The code is more verbose. However, isn't it easier to understand and find the raise condition when you see the when you see the Go routines and select and for? Isn't it easier also to debug? Now this test is rock solid. We just added an atomic for the external value, and the Go expressions allow complex logic that assertion libraries may struggle to handle. Notice that the standard library has great packages like strings, slices, maps, CMP that can help us with conditional logic in our test. The key idea here behind this topic is understand the assertion condition logic. Do you think everyone using testify knows what is the difference between assert equal and assert same? So kind of this is the answer to the topic of today's presentation. Avoid the use of assert libraries to help your test. The assert packages create a whole new sub-language. Assert libraries make it too easy to write imprecise tests and inevitably end up with duplicating features already in the language, like expression evaluation, comparisons, SIM tests, even more. But it doesn't mean that I'm going to finish the presentation right now because it will be too short. And I have more to say why avoiding assertion libraries is good. So let's dive into equality assertions topic. Look that in this test, testify finds the timestamps not to be equal. However, this is the exact same moment in time. It's just in two different locations. So this is just a fragment from the time docs. It basically says that the equal operator compares not just the time, but other fields like location and monotone clock. So you should use the equal method instead for comparing times. So usually testify equal works as expected. However, as you can see, not always. The reason is that assert equal uses reflect deep equal for comparing two values. Take into consideration that, for example, value from slog is not even a comparable type, and you can still use testify assert equal, and it will make your test very fragile and subject to unexpected behavior if the underlying implementation changes. Here is how we can write the test without using testify. But then what should we use for comparing more complex structures? When you need a deep comparison, the Go guidelines recommend using GoCMP maintained by Google. This package is intended to be a more powerful and safer alternative to reflect deep equal for comparing whether two values are semantically equal. The primary features of CMP are when the default behavior of equality does not suit the test needs, custom equality functions can override the equality operation. So it's basically you can put custom equality operations, and types which already have an equal method may use that method to determine equality. So because of this behavior, oh, sorry, this is an old one. Using GoCMP package gives you clearer diffs and avoid issues with unexported fields, and it reuses the equal method from the time type. So this test passes basically. And it's even in the official test comments. Use CMP equal for quality comparisons and use CMP diff to obtain a human readable diff between objects. Reflect deep equal is sensitive to changes in exported fields and other implementation details. And notice that assert equal uses reflect deep equal in its implementation. Now let's explore something more than just writing assertions and discuss the patterns used for structuring tests. Let's see how test code structures using testify suite package that follows XUnit framework conventions. We have a power handler test suite here, which contains 3 test cases. There's a setup test method, which is executed before each test, and tear down test that is executed after each test. Make request is just a helper function. And here is how we can write the same test without using testify by using the table-driven tests that are idiomatic in Go. Testing T already provides methods like, I'm not sure if it's here, like trun. There's also like tcleanup. There are also thelper that you can use to structure your tests. Test frameworks like Testify Suite, Ginkgo, GoConvey introduce XUnit or RSpec test structures. They may be idiomatic in other languages, but they are not considered idiomatic in Go. And they can also limit the flexibility of the Go testing framework. For instance, Testify has a long-standing issue that you cannot use. They do not support parallel test at all. Google Go Style Guide has a lot to say about structuring tests, and I highly recommend reading this style guide because there's a lot of knowledge inside. Here I have some list of patterns related to structuring tests from this style guide. First, use table-driven tests and subtests for structuring tests. Second one is create test helper functions for setuping or cleanup tasks inside your test. Third one, which is interesting, is to create validation functions that return a value, typically an error or a string, rather than taking the testing t parameter and using it to fail the tests. So basically, the helper methods should not be failing the tests. If all tests in the package require common setup or tear down, you can also use the custom test main entry point for the whole package. If you want a more complex example, here is the QR code which you can scan and use later for homework, because it basically shows how all of these examples can be used in practice. And basically, this is like this example is inspired on integration tests from OpenTelemetry. Give you a few seconds. Okay, I'll also publish the slides later. The Go standard library provides the testing package. This is the only testing framework permitted for Go code in the Google code base. In particular, assertion libraries and third-party testing frameworks are not allowed. And the same basically applies for all repositories maintained by the Go team. So for example, if you want to add something to the standard library of Go, the same thing applies. A few words about interaction testing. Before we dive into the example, a quick preface will help make the next example easier to understand. Testing the interaction of the code which operates on interfaces is not straightforward. And in particular, OpenTelemetry Go Logs API consists of many interfaces and abstract factories. So testing code which uses Go Logs API is not straightforward at all. AutoZap is a bridge that provides a Zap core so that testing the existing code that already uses Zap for emitting logs can be passed to OpenTelemetry. And let's look how tests for AutoZap can look like. We have some test cases here. I do not have a cursor. This will not work. Here we have test cases, which basically show like this is what the code will do and what we'll expect that will be landed into the OpenTelemetry logs. So basically, if we put an info with a message, we expect that it will be transferred to OpenTelemetry like that. And this is another example. So basically, it is a table-driven test. And this is how the execution, that was the table, the test cases. And here we can see how the implementation of the test look like. So we have a recorder. This is a fake implementation of OpenTelemetry logs. And basically, the table-driven test uses GoCMP here to verify if the log bridge, which was created here and passed here, and then the function was called here, that the bridge has emitted expected log records to the recorder. So here's my personal code. Favors state testing over interaction testing, as it results in tests that are less coupled to the internals. When simulating dependencies, prefer using fakes or record replay proxies instead of mocks, as they tend to produce more robust and maintainable tests. So in this scenario, when the tested code is interacting with interfaces, it can be very tempting to look into mocking. However, from my experience in Go, we favor state testing whenever possible. And when interaction tests are necessary, fakes or these record replay proxies, like for the standard library we have, for instance, response recorder in HTTP test package, give you better control than mocks. I've seen many cases where test passed, but the code didn't actually work because the mock setup was actually incorrect. So the tests were failing not because the actual implementation was wrong, but just the mocks were not correctly being set up. And mocks couple tests to implementation details that can change as your code evolves. And at last, avoid mocking libraries like testify mock and go mock. Prefer simple handwritten mocks. When testing, and this is from a Google style guide, when testing component interactions, especially where HTTP or RPC are used as the underlying transport between the components, prefer using the real underlying transport to connect to the test version of the backend. Basically, Go says that if you can use the real thing, try use like mocks when basically, I don't know, when it's really necessary. And this is the bonus thing which I wanted to add as the last one. A quick detour about dependencies. Another, in my opinion, very big advantage of not using assertion libraries is reducing the number of dependencies. Eliminating unnecessary dependencies simplifies the development and reduces maintenance. Moreover, please imagine the community's frustration if Testify will change its license or will not longer be maintained. Or worse, if a bad actor will add malicious code to init function to the assert or require package. Every new dependency adds complexity and risk. As Rob Pike said, a little copying is better than a little dependency. Sometimes it's better to write a few extra lines in test code than import an assertion library. Let's wrap up. Follow Go test comments and Google's Go style guide. Use the standard library for structuring tests. It's simple yet very powerful. Use Google's CMP package for comparing complex structures. And at last, I have to confess that I've used Testify for many years and we continue to use it in OpenTelemetry Go. Rewriting all existing tests will be probably a waste of time. However, for new code bases, we should avoid using assertion libraries and test frameworks. To learn more, I encourage reading the test code maintained by the Go team, especially the tests of the Go standard library. Write good tests and boring Go code. It's the best kind. Thank you for listening to the presentation. Feel free to give comments and ask questions, and here's a hyperlink to this presentation. Thank you.
Who disagree with Robert? Oh, sorry. I just wanted to ask if there are any questions. Questions, comments, complaints. This is the time because, no. Okay.
At the beginning of your presentation, you showed a bunch of books, and one of them was a book written by Grzesiek Gęsowski.
Yes.
Did you had a chance to speak with him or meet him in person?
Yeah, I met him. Yes, he lives in Krakow. He works in Motorola.
Yeah, I used to work with him in one team, and yeah, I read that book many years ago, but as I remember in that book there was a lot of content that focus on the assertions, on the custom assertions that may simplify your code testing. As I remember, there was a statement that you should never use assert true, and yeah, what is your opinion? Yeah, because it's in completely different It's in the opposite of what you say at that presentation.
Okay, so first I will say a little history, at least from what I know. So even the first unit test framework, which was written for small talk, I think it was called like S-Unit or something like that, which was created by Ken Beck. So even the initial one had this custom assertion functions. I think in this book it is described from Ken Beck. Basically, he created the test framework at Plain, if I remember correctly. So he had it initially, but the thing which the creators of Go basically saw is that the thing which you need actually is not, you just decouple the condition checking from emitting the error and give the chance for the test code to decide what to do with the error. So it doesn't mean that you still can have this kind of assertion helpers, but the assertion helpers are called in this Google nomenclature validation functions. So these are the functions that return the error or some, for example, CMP_diff returns what is different. So basically, you just put the content which you see in the failure message just in the error on the or the string, and this gives you just more flexibility. This where structure you can decide if the test should stop and fail, or you can also combine multiple conditions. For instance, when you're using XUnit, you cannot make an OR. Everything is an AND, right? You cannot one by one this assert on this assert. If you use simple conditions, you can do it very simply. So a question, have I answered your question or not at all?
Yes.
So yeah, and this was also difficult for me personally, and I also struggled months to switch my mindset. And yeah.
And if I may I ask another question?
Sure.
Yeah, I'm not a Golang developer, so forgive me the lack of knowledge. It's not clear for me this topic related to mocks and fake. What's the difference? Can you explain me?
Okay, so there's a great article called, I think, about test doubles by Martin Forwer, and I think it's called "Mocks Are Not Fakes" or something like that. So basically, the idea is that I will try to say it in my words. So basically, fake is a fake implementation. So for instance, if you have a fake of a database, it's something that works like a database in memory. And a mock is something that you just that you programmatically like say, oh, if I expect that this guy called for example insert or set. So they are very tightly coupled on the interactions. So fakes are more concerned on the state. So they're implementing the state is in the internals. So for instance, if you are using fakes, you often are not able to determine which was called first.
Okay, I catch. So for database, you may replace Postgres, for example, by SQLite, yeah?
Yeah,
but,
kind of.
What's if I want to replace HTTP server or something like that, or gRPC server?
Okay, so there are a couple of ways. So for instance, you can write, it depends how far you want to replace it. So the Google team says you that if possible, use the real gRPC or HTTP server in your test. Just run it locally. But if it's something external that you're not able to control, then there are other patterns. So one of it is there's an HTTP test package, and it provides you creating handlers, like little servers just for testing, or HTTP response recorders. This is one approach. So these are kind of a little bit kind of something between a fake and a mock. The second approach is using record replay proxies. So in Go, I know there are two packages when you can record basically record some, just put a proxy between, between something what you actually call in the implementation. It will record you'll get a file, and you can then put it back to your test suite. So next time, when you after recording, you can use it in your unit test. So it just uses this file basically to replay this interaction. And I can also show, there's one cool project. I'm just not sure if I'll be able, give me a sec. There's one very powerful one. If you need something very advanced, you can use at Meeting Proxy, which is a very powerful, I think you know it very well. Yeah, so it's a very powerful HTTP proxy, which pen testers are using. And you can also, I think, use record, replay stuff. You can play with certificates. And basically, it's a separate tool, but it's so powerful. And you can use, CLI to control those kind of stuff.
Okay, so I promise that's my last question. So,
No, it's fine. These are very good questions, I think.
So in the unit test, do you use, for example, a meet proxy? But if yes, it's against with the first acronym of test, that test should be fast, independent, and so on.
Yes, but what does it mean fast? That's the question. Yeah.
So I guess it depends what you are testing and how do you want to test it. If
Yeah.
you are just testing some Go implementation where everything is written in Go, you don't really need a tool like
Yes.
this. But for example, you can imagine that maybe you are doing some end-to-end testing and like you are from Go, you are calling some external binary that will then issue HTTP requests and you want to mock those, then maybe Meet Proxy is good for that.
You should have a mic. We have a second one.
But generally speaking, Meet Proxy is more for like, just testing how or interacting with how different apps work or programs and maybe having them eventually.
I have forgotten the word. It's an integration test, basically. It's normal an unit test. It will run slower. But also regarding this unit test, if it can run in one process, usually for me, if it's run under if it runs 100 milliseconds, for me, it's still a unit test.
Okay, thanks.
Thank you. Other questions? Go on.
Yeah, quick question. Thank you so much, Robert, for presentation. And you show up a lot of different approaches. And I was wondering, what are your thoughts on AAA approach for writing tests? Got it right. Arrange, act, assert. Yeah, because in some examples I haven't seen that.
So if you look deeply, it's still there. Like maybe if I pull the examples, I just need to go back to this here, present. Shoot, I do not know the shortcut. Focus. So I would say, first of all, this kind of thing still applies. This is the act. This is the assert, right? If you go to the next example. Yeah, same. So here we have, assert, act, arrange, act, assert. And even if you have the table data-driven tests, the more complex one, this is harder. I agree, this one is harder, but these are you have Go routines here, but you can still kind of see that this is kind of act, right? And here is the assertion logic here. This is all the assertion logic. This is basically assertion and act. Arrange as well.
Yeah, got it. Now it's clear. It just I more get used to put empty lines after every section.
I have not done it because it will make this
presentation.
Slides.
Yeah, makes sense. Makes sense.
Usually we do it. Usually before checking before doing these assertions, we sometimes put a blank lines to just make it visually better.
Yeah, got it. Thank you.
Thank you.
Thank you. In general, I really liked your presentation because in all the teams I was working for and I am working in currently, I am strong advocate of not using testify when possible. But in the same time, I don't know if it's the question or an open discussion.
Yeah. We are on a meetup.
Sentence. But in the same time, I don't really like the approach of doing A or B, like we use testify or we don't use it at all, because it really shows how our industry work a little bit, like where we were in monorepos and then we jumped to the to microservices and leave them away, and now we are returning to monorepos, but not in the same way. And for example, when we speak about the AAA, I tend to use testify for the arrangement phase, because in most cases, at least in the
You mean assert
uh,
phase? Testify?
no, when I create the variables at the beginning of the test, in most cases, it's become even bigger problem when I do it with the testing table. And it's in most cases this is because I tend to create a lot of variables that return error, like when I create structures or something like this, but these are not part of the test.
Yes.
Because I tested it elsewhere. So I require no error, for example, just not to overwhelm user to look through 100 lines of code where I only if error do log error and stuff. So I wonder how you approach this when you, of course, in example like this, you can go with your idea and it's fine, but in code bases, in most cases, you need to create a lot of stuff that returns an error, and
Yes.
you don't really test these errors,
I
right?
think I understand your question. So you say about the thing that your test can fail even before going to the assertions, where you're setting up like the arranging basically the test.
Yeah.
So if you read the Google Go guidelines, they say you can, to the helpers, to the setup helpers, you can pass this T, and if it's a failure connected to the test setup, you can fail in the helper. It's just the thing that this test, this is not the key of the test, right? So the thing is that basically they say use this if return in the places where it matters.
Yeah, okay.
This is the thing when you want the reader to look the code, you want to see, this is the meat basically. So you can, if you have this, I don't know, basically, I think I have it even in the, I think I should do this for you if you asked. Structuring tests, and not here. I think I have it here.
I haven't gone through it yet.
No, sure, it's a homework. You're not at home. So here I think, so here there's a setup. And in this setup, as you can see, we are failing.
Okay.
This is just creating a real connection to the database, and that it fails, we just fail the test in the setup, which is kind of hidden if you look at the test code, because if you see the table data-driven test, which is still very long, but setup is here, right? So basically this line will fail.
Okay.
Have I answered your question or not?
Yeah.
Okay.
More questions? Just remember that you can disagree with Robert.
Of course. And disclaimer, this is not the code from OpenTelemetry. It's just how it would look like if we would refactor it. But it just doesn't, like you said, that sometimes it doesn't. You need to be pragmatic. It doesn't make sense to rewrite the code bases because now the Google team says that we should not use it, right? It just works, so we are still using testify. Okay.
Yeah, so you showed and talk about the array-driven test where you have like this, we define the struct and we iterate over the structs. So I use it often, but my problem sometimes is that I kind of try to stick to, for example, let's say like sunny day scenario and test all like input output, but my functions and my processes also output some errors, which I start to test in this sub-tests.
Create separate tests.
Yeah, and my main question is, do you have some rules like when should I create new test instead of sub-tests? Like which like the sub-test is simple enough, and when do I cross this line and start to create separate tests.
I will quote Robert and Miłosz, there's no silver bullet. So basically it depends. And usually when I have this kind of dApps, I try to ask my colleagues which is more readable for them. I think even in the Google, this Google structuring thing, guidelines, they even say that even for one function, you can, for example, have one function who has a data table for positive tests and second for error cases, for example, to not have this kind of if there was an error, because it makes the test code then very awkward that you have an if when there's an error and other when there's a real result. So yeah, this is like it kind of it depends. Is it a good kind of
Yeah,
acceptable
thanks.
answer? Thanks.
More questions? If not, I encourage you to stay because we will have a lightning talk, about the mutexes. So sometimes that's more complicated than the test. So feel free to stay with us if you have a time.